Welcome to AS Physics. Today we will do the MCQ based questions for the first chapter of force for ICSE 10th standard. So let us start. First chapter we are going to start, that is the force for ICSE 10th force. First question we are going to start. What is the first question? Force is equals to, so we know force is equals to mass into acceleration, right? Force is mass into acceleration. We know F is equals to ma. So simple way. So what we have to choose here, options are given: mass into velocity, mass into time, mass into acceleration, velocity into acceleration. So since F is ma, m is the mass and a is the acceleration, so it will be this B option. So we'll choose B is the correct option. Okay, now we'll do second question. Which one way to reduce the moment of force about an axis of rotation? First of all, I want to tell you what is the moment of force. So moment of force is represented by tau. It is defined as the product of one force and perpendicular distance from axis of rotation. Perpendicular distance from axis of rotation. This is the term. This is the torque. Now we have to, and simple way in formula form we have tau is equals to R into F. Moment of force is R is the perpendicular distance and F is the force. So here in question it is given give one way to reduce the moment of force. So we have to reduce tau is equals to R into F. We have to reduce the moment of force either by reducing R or by reducing F. So what will be option? Decreasing the perpendicular distance, of course, that is R, by decreasing R. Increasing the perpendicular distance, it will increase, so this will not be option. No change in perpendicular distance, then it will not reduce. None of the above, it is also wrong. So decrease in perpendicular distance is the correct option. We will choose A as the right answer. Next is a rotational motion around a fixed axis is an example of rotational motion around a fixed axis is an example. If one axis is fixed, like door is there, as we apply the force on it, it is the handle say, and this is the axis of rotation. As we apply the force on it, it start to rotate. So it produces rotational motion. So what will be answer? Rotational. Now next is question number 4. When a rigid body is acted upon by a force, how many different types of motion can you observe? When a rigid body is acted upon a force, when a rigid body means one end is fixed, how many different type of motion we can observe? So simple way, two kind of motions may be there. One may be rotational, like we can take the example of the door. As we push the handle, it start to rotate. And second is the linear motion. When one end is fixed of the door is there, another end can move. So we can simply say that translational as well as rotational motion. When force is applied on any body, then it can have two kind of motions. One is the translational, another is rotational. So what will be answer over here? Different types of motion may occur over here. Now question number 5. What is the question number 5? When an object moves at a fixed distance from the axis point, what type of motion is it? It will have which kind of motion? When an object moves at a fixed distance from the fixed point. Point is fixed and object is moving across it, then which kind of motion will be there? It will be circular motion. So answer will be circular motion. Next, torque. A torque is torque is R into F. From here we have to decide. One is the force applied, another is the perpendicular distance. Both are correct. It does not depend on the pressure. So both A and B, force and distance. So answer will be T. Next question, question number 7. CGS unit of force. CGS centimeter gram second. Unit of force. So we know unit of force is Newton, that is SI unit is Newton, and CGS unit is dyne. 1 Newton is equals to 10 raised to 5 dyne. That's we know. We have to remember it. In next question probably they are asking the same thing. So that is dyne. CGS unit of force is dyne. And 1 Newton is equals to how much dyne? We can calculate 1 Newton. Newton is the unit of force. It is mass into acceleration. And if we are writing mass as 1 kg and acceleration as 1 meter per second square, then it is the force. And 1 kg is 1000 gram into 1 meter is 100 centimeter into per second square. So this term is 10 raised to 5 gram centimeter per second square, and this term is nothing but dyne. So we get 1 Newton is equals to 10 raised to 5 dyne. So this relation we get. Here 1 Newton is equals to how much dyne? So it is 10 raised to 5 dyne. So directly we can write as A as the answer, 10 raised to 5 dyne. Next question is here, of moment of force, the moment of force 10 Newton about a point O is 50 Newton meter. Moment of force 10 Newton. So it is given F is equals to 10 Newton. And moment of force which is represented by tau, it is 50 Newton meter. Calculate the distance from point O. So we know since tau is equals to F into D or sometimes F into R. R is the perpendicular distance from axis of rotation. So we have to calculate D. So D will be tau by F, and we have tau is equals to 50 by 10, that is 5 Newton 5 meter. It will be 5 meter. So anywhere option is here, of course, that is 5 meter. So B is the correct answer. Next question, a nut is opened by a wrench of length 20 centimeter. So wrench of length can be considered as D, distance 20 centimeter, which is 0.2 meter, right? 0.2 meter. And least force is given, F is as 2 Newton. The moment of force, since tau is equals to torque is moment of force, so it is F into D. So F is already given, 2 into 0.2, that will be 0.4 Newton meter. So torque is 0.4 Newton. Moment of force is nothing but torque. So it is 0.4 Newton meter that we can have. Now next question is question number 11. When a body is placed on a tabletop, it exerts a force equal to its weight downward, but it does not fall or move. What is the direction of the force? Direction of force is the vertically downward due to acceleration due to Gravity, because earth want to attract all the object towards its center. So its answer will be vertically downward direction. Now question number 12. Which of these moments is considered negative? So of course we have studied clockwise moment is considered as negative, anti-clockwise is taken as positive, and it is given by the right hand screw rule. As we rotate the screw in clockwise, it goes inward, and inward is the negative z axis. So clockwise is taken as negative, and as we rotate it anti-clockwise, then screw comes up, and that direction is taken as positive z axis. So that is positive. So here we will get which is considered as negative. So that is the clockwise. So clockwise is considered as negative. The unit of moment of couple, once again I will say moment of couple, that is torque is R into F, unit of force is Newton, unit of distance is meter, so it is Newton meter. So answer is Newton meter. Next is question number 14. When a body is at equilibrium. So at equilibrium we have already studied according to principle of moments, total clockwise moment is equals to total anti-clockwise moments. So here it is given the sum of anti-clockwise moments is equals to sum of clockwise moments. That is the C is the correct option. Now next is a couple constitute of. So what is the couple? Couple, when two equal and opposite forces are acting, this I can say F, this is also F, and they are separated by a finite distance d. This is the couple. So a couple consists of two equal and opposite forces, and they are separated by a finite distance d. So a pair of equal and opposite forces whose line of actions are same, not possible. The pair of equal and like forces whose line of actions are same, no. Pair of equal and opposite forces whose line of action are not same. So of course this will be there. A pair of equal and like forces whose line of action are not same. Here equal and like forces, but opposite forces must be there, as I was drawn the diagram. Here forces are in opposite directions, so the option will be C in this case. Okay. Next is question number 16. The center of gravity of a hollow sphere lies, center of gravity of hollow sphere. Of course, hollow sphere is there, its center of gravity is always at the center. So its geometric center we can say. So the option will be D. Next question is question number 17. The center of gravity of a triangle is triangle where its median intersects. Where its median intersects, at that point gravity is there. Now question number 18. Center of gravity is usually located where? Basically where center of gravity located? Center of gravity and center of mass are very similar. Center of mass is the point at which whole mass of the body is supposed to be concentrated, and center of gravity is the point inside the body at which whole weight of the body is supposed to be concentrated. So here we can say where its weight will be supposed to be concentrated. So of course that is given to us. The center of gravity is usually located where its more weight is concentrated, where its weight is supposed to be concentrated. Next is question number 19. The center of gravity of a hollow cone, where its center of gravity exists, this height is HA. So of course it is at 2h by 3. We know this relation, 2h by 3. Right? Next is Question number 20. The point through which the whole weight of the body acts is called its अभी मैंने बताया कि what is the center of gravity or center of mass of the body. It is the point at which whole mass of the body is supposed to be concentrated. So whole weight is supposed to be concentrated or whole mass is supposed to be concentrated. That is the center of gravity, of course. So its answer is center of gravity. Now question number 21. The point at which the total area of the plane figure is assumed to be concentrated is called, the point at which total area of the plane figure is assumed to be concentrated is called area. That is the centroid. That is the centroid. Question number 21, that's answer is A. Now question number 22. Where does the center of gravity of a uniform rod? This is the uniform rod, so of course it will exist at midway. So at its middle point, we can say, at its middle point. Next is question number 23. Where does the center of gravity of a circle lies? Center of gravity of the circle, of course it will be at the center. No doubt about it. At the center. What would be the center of gravity of the following section? So of course it will be at this, where its diagonal intersect to each other. So we have to calculate it. Of course this point, where this point will exist, it will be center of this one. So center of this one is 6. One point is 6. So 6 is in 3 options. Another is half of this, where the center will exist at this point. So half of this, half of 3 is 1.5. So 6 and 1.5. X we write first as x. So 6 and 1.5. So of course it will be C. In a uniform motion, which of the following remains constant? In uniform motion, what remains constant? Velocity is a vector quantity, so of course direction is going to be changed every time, so velocity is not constant. Acceleration is not constant, velocity is not constant, so this option could not be there. So it will be speed. The speed will be constant. Centrifugal force is, centrifugal they are talking, it is a pseudo force or imaginary force. Pseudo or imaginary or fictitious, 3 words are there. Pseudo, imaginary or fictitious. So all have the same meaning. Okay. The mathematical expression for the centripetal force is, so we have a study, centripetal force is F is equals to mv square by r, one formula. Another is m, since v is equals to r into omega, this is the relation between linear velocity and angular velocity. That concept we can use over here, this formula. So instead of v, we can write r into omega. So this term will be r omega, that's whole square by r. So it can be written as m r square omega square by r. Now r cancel, we are getting mr omega square. Mr omega square. But there is no such option, mr omega square. So we can cancel it and we can write mr omega square. This is the expression for the centripetal force. Now this is correct one, mr omega square. Next is question number 28. If a body of mass 10 kg, so m is given as 10 kg, is moving with velocity, v is given, in a circle of radius this, what is the centripetal force? So of course this formula already we have written, mr omega square or mv square by r. So what informations are given, just we can write m, mass of the body is given as 10 kg. V is 5 meter per second and R is the radius, which is 5 meter. So centripetal acceleration, since centripetal acceleration, okay, we can write, since centripetal acceleration we have ACP, acceleration centripetal, it is V square by R. No need to substitute the value of m over here, it is V square by R. So phi square by R is phi, so of course it will be phi. So unit of acceleration is meter per second square, so it will be 5 meter per second square. Next is question number 29. The centrifugal force is always acting. Centripetal is always acting towards the center, it is centripetal, and centrifugal acting away from center. So centrifugal away from center, directly we can say. Now question number 30. A body moves in a vertical circular motion. What force does it not experience? If any body is moving vertical circular motion, what force it not experience? That is the centripetal force. Which force does it not experience? Of course, it will not experience centripetal force. Which one of the following devices act as on the principle of circular motion? So, which device is there which works on the principle of circular motion? Centrifuge machine, like our washing machine is also kind of that machine. So answer is centrifuge. At what position in the vertical circular motion is the string's tension the least? When it is at topmost position, then tension in the string is least, and sometimes it will be 0 when it will just complete vertical circular motion. So where it is the least? At highest position. Next is, which of these is the cause of uniform circular motion? So of course centripetal force. In which of these motions can be speed by constant linear motion and uniform circular motion? So by both we can speed up. So both of these is the answer. Next is question number 35. On what factors does the position of center of gravity of body depends? On what factors it will depend? Only shape? No. Only distribution of mass? No. Shape and distribution of mass? Of course it will depend. Next is question number 36. A uniform meter rule is balanced horizontally on a knife edge placed at 58 centimeter mark. This is the fulcrum or balancing point when a weight of 20 gram force is suspended from the one end, 20 gram. What has been asked? What is the weight of the rule? So weight of any body exists at its center. So what is the center over here? Overall it is meter rule, so 100 centimeters, so at 50 it is mg. So we have a study, if it is at equilibrium, then total clockwise moment is equals to anti-clockwise moment. So what is the clockwise moment and what is the anti-clockwise moment? In this case, this distance will be 8 centimeter and mg is there, and this distance 58 minus 100, 100 minus 58, it will be 100 minus 58, which is 260, 42 centimeter. So We have studied according to principle of moments, clockwise moment is equals to anti-clockwise moment. This will form which kind of moment? It is clockwise moment, and this will form anti-clockwise moment. So now we can say 42 into 20 is equals to mg into 8. 8 ones are 8 six are. So mg is equals to 620. Once again I will say weight of the rule. Weight is mg. Mg is to be find out. Of course it will be 100 minus 58 is, this is 58. All the distances are measured from fulcrum. 60, 42, right? This is 8, 8. No, I am making wrong 8. 8, this. Once again I will write. So 8 into mg is equals to, instead of mg we can write weight. W is equals to mg is equals to 42 into 20. So 4 to side, 4 5 are 2, 21. 21 5 are 105 gram force. So A is the correct option. Now question number 37. Where is the center of gravity of a uniform ring situated? So रिंग है तो रिंग का हमेशा कहाँ पे रहेगा? सेंटर ऑफ ग्रेविटी उसके सेंटर पे. तो ऑफ कोर्स इट्स आंसर विल बी एट द सेंटर. नेम ऑफ द फोर्स रिक्वायर्ड फॉर यूनिफॉर्म सर्कुलर मोशन. ऑफ कोर्स इट इज एवरी टाइम centripetal force. A, B and C are the three factors each of magnitude, forces of magnitude 10 Newton acting on a plane of the paper shown in the diagram. Which force has the least moment of O? Least we have to mention. So let us see. Force is 10 Newton everywhere. This 10 Newton, this 10 Newton, this 10 Newton. Moment of force is tau is equals to R into F. Now, if distances, okay, distance and force. Force is 10 Newton everywhere. Force is 10 Newton every time. So, where the distance is large, that will have more moment, and which will have a smaller, that will have the least moment. So, simple we can say, here we will get 10 into 0.1, no 1.0. So, it will be 10.1. This will be 10 into 0.8 is 8, and here 2 into 10, that is 20. So, least we will have in second case. So, answer is about this C point. So, C is the right answer. Next one is question number 40. What provides the necessary centripetal force in the following cases? Electron moving around the nucleus. So we know if any electron, this is nucleus, neutron and proton, electron is moving. So electron should fall inside the nucleus, because nucleus contain positive charge which is the proton, but electron have negative charge. So it should fall inside the nucleus, but it doesn't fall because necessary centripetal force is provided by the electrostatic force of attraction between electron and proton, or electron and nucleus. So electron moving around the nucleus due to which force? Electrostatic force. Moon moving around the sun due to gravitational force, because between moon and earth there is the gravitational force. Wheeling of a stone tied in a string, of course it is centripetal force. And motion of a planet around the sun, motion of the planet around the sun, of course it will be motion of the planet. Planets are the heavenly bodies, so they are considered to be as masses. Where is the center of gravity of the following object situated? रिंग का कहाँ पे होता है? उसके सेंटर ऑफ सर्कल पे. इट इज एट द सेंटर ऑफ सर्कल. नेक्स्ट इज रोम्बस. रोम्बस का कहाँ पे होता है? रोम्बस उसका मिड पॉइंट ऑफ इंटरसेक्शन ऑफ डायगोनल्स, वी कैन से इंटरसेक्शन ऑफ डायगोनल्स. Scalene triangle, it will be at the center of circle. Cylinder, midpoint of the vertical circle. Yes, पहला ही right है. Question number 42. Name the unit of physical quantity obtained by the formula p square by 2m. तो हम लोग देखें मोमेंटम P इज इक्वल्स टू क्या होता है? mv होता है. mv, राइट. सो यूनिट ऑफ फिजिकल क्वांटिटी. ओके, यहाँ आंसर में हमको ना जूल के टर्म में दिया, मतलब एनर्जी के टर्म में लिखना है. सो आई कैन राइट, आई विल स्टार्ट विद द काइनेटिक एनर्जी. सिंस काइनेटिक एनर्जी इज इक्वल्स टू हाफ mv स्क्वायर. नाउ मोमेंटम इज p, product of mass and velocity is p. So that we have to write in terms of p. So we can say half m upon m into mv square. Now we can take this value as p square. So it will be kinetic energy E will be half P, I think so, half mv square, right? So mv is p, we can write mv to the whole square upon m. So mv square is p square. So overall we will get E is equals to, we can write it, no problem. E is equals to 1 by 2 p square by m. So p square is equals to 2em. So p becomes root of 2em. Okay, 2em. So overall we require what? हमें चाहिए कि momentum and m is the mass, m in terms, m चाहिए. तो we can learn from this step. इस step से हमें क्या मिलने वाला है? हमें मिलने वाला है m इज इक्वल्स टू पी स्क्वायर बाई 2e. p square by 2e. So name the unit of physical quantity obtained from p square by 2m. So p square by 2m if we will do, sorry I have made it wrong, p square by, sorry, p square by 2m, that will be kinetic energy. So energy is p square by 2m. Okay, so p square by 2m is the energy and unit of energy is joule. So joule is the correct answer. Question number 43. How is the unit electron volt related to the SI unit? So 1 electron volt I can write over here, since V is W by Q naught. So W is equals to Q naught. W will be Q naught into V. So charge into electric potential is potential energy. So unit of charge is 1.6 into 10 raised to minus 19 into 1 volt. Of course it will be. So its answer is B. charge on electron into 1 volt. So 1.6 into 10 raised to, minus 19. It will not be plus. Minus 19 joule. 1.6 into 10 raised to minus 19 is the right answer. Now question number 44. The point through which the whole weight of the body acts is called, that is called the center of gravity. Number of times we have a study about this term. A windmill is paused by the 4 external forces as shown in the diagram. Now calculate the force F required to stop the windmill from the running. So we can say total, once again we can say total clockwise moment is equals to total anti-clockwise moment. So according to principle of torque, we can say principle of this. So total clockwise moment is equals to total anti-clockwise moment. So this and this both are in opposite, So we can say, and how will find out the moment? It is the force into perpendicular distance. In every case is given. So we can say F into 4 plus 3 into 2 plus 2 into 2 plus 3 into 4.0, that is equals to 0. So sum of all the moments at a point is 0. That is the principle of moments. So you will get 4F minus 6 minus 4, plus 6 plus 4 plus 12 is equals to 0. So 6F is equals to 6 4 12 12 24. So F will be, it is 4F, 4F. That is we are doing something wrong. 6 plus 4 10, 10 plus 12 22. So 4F is equals to, we are making something wrong, F into 4 plus 3 into 2 plus 2 into 3 it is, 2 into 3, that was mistake, 2 into 3, then 4 into 1, I have made it wrong, 4 into 1 is equals to 0. So 4F plus 6 plus 6 plus 4. So 6 6 12 and 4 is of course 14. 6 6 12 plus 4 16. So 4F is 16, so F will be 4 Newton. That becomes the answer. So F is of course 4 Newton. So 4 Newton is the P. Now next is question number 46. Uniform circular motion is an example of accelerated motion. That is an example of accelerated motion. The principle involved in the working of a beam balance is, for the beam balance it is the principle of moments. One time clockwise moment, another time anti-clockwise moment. Which of the following quantity remains constant in a uniform circular motion? So what remains constant? Already earlier we discussed about this part, that is the speed. A particle moves in a circle of radius 20 centimeter with linear velocity v. Find the angular velocity. Angular velocity in sense omega. So mr omega square, directly we can say, no need to do this much. Since omega is v by r, so v is given 20, no, it is 10. 10 meter per second. So 10 by radius is 0.2. Radius is 20 meter. Why I am writing 0.2? So omega will be 0.5 radian per second. What is needed to open a shut door? Shut door open करने के लिए क्या यूज करते हैं हम लोग? Moment of force. So we complete all the sums of all the MCQs of chapter 4, which is your first chapter.